Good morning, everyone. Thank you for attending this talk. We even have some people from Spain that they just came for this talk, so thanks a lot. Well, maybe they came for other things. Today, my name is Fermín Serna. I'm the Chief Security Officer of Semmle. And today's talk the title is Open Security using one seed vulnerability and automated variant analysis to get rid of an entire class of vulnerabilities. But before we get into that, I want to ask some questions to the audiences. So for the companies that you work for, how many, please raise your hand if your company relies on open source, either applications, infrastructure. Who has not raised his or her hand? If you have not raised your hand, I'm not sure if you don't have phones or tablets or TVs in your office. They probably are running open source software. So the second question that I have is, those companies, do they actually contribute back to open source? Yes? Who works for a company that contributes back to open source? Kind of, right? So then I have a question for you folks. Contribution is a very vague term, right? So, but then the question I have for the people that is like, yeah, I don't know if we contribute enough. It's like, maybe as part of your dependencies on open source software, there's a critical dependency, right? What is going to happen if that dependency, that open source software disappears? Do you have a business continuity plan? Yes, not? Or even, no, okay. But what about, okay, let's not go that extreme. What about if there is a vulnerability, a critical vulnerability in that dependency that your company depends on, right? Do you have any processes around this? So this is a talk that we're going to discuss this type of problems, potential solutions, which I'm going to anticipate that the solutions are industry-wide. There is no single entity that can address this. We're going to call out a couple of partners that they have been trying to, do their part, and we're going to go deep into the details what Semmle does, right? So, without further ado, one second. Without further ado, let me introduce myself. I already did Chief Security Officer at Semmle. I've been at Semmle for the last 3 months. Before that, I was the Head of Product Security at Google, responsible for all products except of Google Chrome and Android. Before that, I was working for Microsoft and some other facts such as I was nominated twice for a Pony Award, won once, and once I owned Charlie Miller's iPhone. So this is who I am. I have a little bit of history in product security. I have a little bit of history in open source security. This is what I did at Google. So this is the agenda. Essentially, we're going to present a problem. This is more like a talk that we're going to present a story, right? So I'm going to tell you my view on open source security. Where's the elephant in the room? What is the elephant in the room? What are the challenges? And we're going to go with partners that they have been contributing and what we're going to do. So without further ado, let's go deep into the high-level part of this talk where we're going to present. So open source security. We have defined a little bit our dependency on open source, and you may have implemented some security measures from private, such as you may potentially have done fuzzing, code review. You maybe have a product launch process that before something goes public, it goes through some security engineers. But security engineers, they are humans, they may miss things. So you may have raised the bar for private code, right? But now we know that we have dependencies on open source. What's going to happen with those, right? Are you monitoring what externals are finding on those libraries? Maybe you're depending on libpng. What about if there is a vulnerability in libpng, right? How are you going to, is the security bar for libpng good enough for you? And what are you going to do whenever someone finds an issue in libpng? Those are the things that we're going to talk about. First of all, I want to frame the conversation about open source in my opinion, open source has won. I used to work for Microsoft 10 years ago, 8 years ago. At that moment, it was not clear if open source won or not. I can tell you that, in my opinion, open source won. If you take a look to this chart, if you go to the top left, those two bubbles, maybe you cannot see them, they are Google and Microsoft. They are the top contributors to GitHub as companies. Microsoft has more than 5,000 people contributing to GitHub during the, I think the chart was 2017. So maybe even now, maybe more. Google has something like 3,000 people contributing to GitHub. We did a little bit of data gathering here, and almost everyone on their companies, they rely on open source. So to me, it is clear the trend. It's like open source has won and open source is here to stay. Now, the question is, does it come out with the security standards, the security guarantees, the security bar that we all wish? You control what happens inside your company, but once you depend on something outside the company, it's tricky to assess that, right? You may be able to assess it for libpng, but what about the other 200 dependencies that your company relies on, right? And it comes with challenges, as we mentioned. We have the code quality, also supply. Where are you going to download this thing? Does it come pre-backdoor? Is it going to be backdoor in transit? Another thing such as when these open source developers develop, and whenever they check in code, do they go through this code review process? Do they have a public email contact for reporting security vulnerabilities? Or is it a public mailing list that once you report a vulnerability is public? We don't know that, right? So it varies a lot, right? And also another elephant in the room is the CVE tagging. And we will talk more a little bit about this, but CVE tagging works extremely well on private code companies. There is an incentive. There's an incentive on this private code to have correct metadata around CVEs, but on open source, it doesn't really work that well, right? Because there is not paying customers behind this. So the elephant in the room, we did some survey here. Almost everyone said that they were dependent on open source, but 78% of companies, they literally say that they rely on open source security, open source. My take on this one is that there's 22% that they still do it, but they don't know, which is crazy, right? So here you have other stats, such as 50% of them, they literally are saying that they don't have a process to catalog and to follow with vulnerability management on open source, right? And there was another stat here, the 27%, that they don't have a formal policy around open source contributions. So they depend based on their, they have a critical dependency, as we previously mentioned, on open source, and they are not paying back in terms of contributions. And 27%, they don't know if they are paying back or not, right? So it is crazy. You may have, again, a dependency on FFmpeg, libpng. Who knows if it's going to go, they're having a party. Who knows if it's going to go well, go bad in 3, 4, 5 years. So if you have a dependency, please make sure that that thing is there for the next couple of years. So this is the elephant in the room. Open source has won. Companies, they either like it or not, they depend on open source, but it comes with challenges. The first thing is what we already mentioned, CVEs. It works extremely well in closed source software. Companies like Microsoft, Apple, Oracle, they have an incentive to each vulnerability that they have, tag it with a CVE, but not only tag it with a CVE, tag it also surrounded by good metadata in terms of which versions they are vulnerable, maybe mitigations that you could put in place, etc., etc. This doesn't work in open source. Question for the audience, how many vulnerabilities were disclosed to FFmpeg? FFmpeg is this library for encoding and decoding videos. Google, my previous employee, has a multi-billion business around FFmpeg. It's called YouTube. How many vulnerabilities happened in FFmpeg since 2005? Question? More than 10? Maybe yes, right? More than 100? Maybe yes, right? No? Yeah? More than 300? Maybe yes. Nico, more than 500? You say 500? So the FFmpeg has 351 CVEs during 2005. What it's telling me is that the CVE system is not working because as part of my Google job, we found 2,000 vulnerabilities that they were not tagged. So at Google, we did a decent job because we know which one they were. But what about any other company that they rely on FFmpeg? They are screwed, essentially, right? So CVEs work very, very well. In open source, they don't work very, very well. And this is a quote from an email that was sent to OSS security at the open world mailing list, which is essentially they were calling out, Google, you guys are doing amazing. You are finding 9,000 vulnerabilities as part of the open source fuzzing project, but it's not working very, very well because, okay, you find it, they get fixed, but they are not tagged as security issues. And then companies, they don't know if they need to upgrade or not, right? So this is the other elephant in the room, CV tagging. Can anyone spot the vulnerability here? This is a code checking into the Linux kernel in 2003. Sounds like it's legit. Sounds like someone was trying to find if some options contain some flags, and then it was going to return inval. Okay, so my question for you guys is that if I haven't told you that there was a vulnerability here, would you have spotted it or not? By the way, the vulnerability is here. There's an equals here, which is essentially, if you run this code, it will give to your user mode process root privileges. This is a backdoor that went into the Linux kernel in 2003. Commonly, people think like open source, there's a lot of eyes on open source, and this is going to be caught, right? Someone else is going through this, right? Someone else, think about this, who? Maybe someone else is going to pick it up, maybe not. Think about the millions of lines of code that goes to any open source project over the years. These things slip through its cracks, right? And this is very tricky to find, right? So how are you going to defend about this? I mean, let's say that you depend on libpng and there's this thing. They are essentially introducing a vulnerability, not a vulnerability, a backdoor into your application, right? How are you going to defend on this? This is something that we expect someone else to do it, but nobody's doing it as a full-time job. Even I will go farther. It's like, no, as a full-time job, you are not going to catch any of those. This is a big problem. Other things, supply chain. Couple of examples. There's a couple of package managers, NPM and Debian, apt-get, and all those things. These companies get hacked. And not only the companies, the developers. So on NPM, on that example, essentially there was a vulnerability that if you install a malicious package, that malicious package is going to run some pre-hooks, post-hooks, and could backdoor your developer account and could backdoor your pre-hook, post-hook scripts, and essentially is making a worm. Whoever installs this is going to backdoor more NPM packages. And this happened. There was a worm, an NPM worm on this one. Also, Red Hat got hacked, and they got access to the signing keys of the RPM packages. Recently, I think Canonical, Ubuntu got hacked. Their GitHub repository got hacked, and people got access to their source code, right? So supply chain, and by the way, this is not a problem only on open source. It applies to also closed source, but I want to call it out here. Other things, and it comes with consequences, right? And I want to call out the Equifax. Who is familiar with Equifax hack? Some of you, right? So I want to spend some minutes on this one. Essentially, Equifax got hacked via Apache Struts vulnerability. There was some data that ended up on Java deserialization function, and it was a remote code execution. The problem with this is that this vulnerability was discovered 3 or 4 months before Equifax got hacked, and there was a publicly available patch. So that's the first thing wrong. It's like they should have known that they were subject to a CVE, and they should have patched, right? But my take on this one is even further. Even if they patched, they were still vulnerable to other things, very, very similar to the original vulnerability. And we will go deeper into these things. And proof of this is that we found at least 2 other vulnerabilities similar to the Equifax hack, that even if Equifax had patched the one that they were subject to, they were vulnerable to the other 2. We will later go deep into details about those vulnerabilities. So TLDR, originally I had a stronger TLDR, that was a mix of Equifax and we're screwed. But I changed it to a more polite, there is room for improvement, we need to call for action. Essentially, there is no single entity in this world that can solve this. I mean, you may think as Microsoft, Google, Facebook, GitHub. There is no single company, single entity that will be able to fix this alone. So there is a call to action to everyone to try to do their part, right? Essentially, if you have a dependency, as part of your business continuity plan, you may want to invest a little bit of money or a little bit of resources on raising the bar, not only on security, but other things on those dependencies, right? So, and well, we spent some time talking about problems. Let's talk about solutions, right? So we already mentioned that this should be an industry-wide thing. And I'm going to call a couple of people that they have been doing some stuff during the last couple years, right? So the first one is Google. This is deep into my heart. I was part of this project. Essentially something called OSS Fast. Who's familiar with OSS Fast? 1, 2, 3. OSS Fast is essentially a service, a free service that we provide, that Google provides to open source packages, where essentially you develop a small snippet of code, a Docker file, and Google will use the immense scale that they have in terms of CPUs, in terms of memory, to continuously fast these open source packages as they keep developing. Not at one point of time and we stop. As there is any new pull request in GitHub, it will be picked up and it will be fast. The idea here is that they want to reduce the time gap between development and someone finding the vulnerability. Okay? So it is free for open source, minimal involvement from the developers. They don't need to know anything about fuzzing. They will just provide the Docker file, a snippet of code, and they will get alerts, right? Impact, they already are fuzzing 200 packages in open source, and they found more than 9,000 vulnerabilities. Other players in this space, GitHub, they recently made announcements around a couple of free tools that they are available for open source. They bought a company called Dependable, and they had a partnership with White Source Security. Essentially, for open source, they are going to analyze your dependencies and they are going to instantly alert as CVEs come. So think about if you are an open source maintainer on GitHub, let's say libx, and you depend on libpng, and libpng contains a CV, within minutes, GitHub is going to alert this, it's going to detect this, it's going to alert you as a maintainer, and it's going to go one step further, and it's going to propose a change to your code to fix this thing. Tremendous impact. Essentially, they are making security easy for non-security people. Other things that they implemented, the security policy, the private reports. This is something that I suffered when I was at Google. We had to report 2,000 vulnerabilities to FFmpeg. How do you do that? I mean, it's not, you may think that there's going to be a security at ffmpeg.org or whatever. Sometimes there is not. Sometimes they will tell you, hey, report this to this public mailing list. Do you really want me to report 2,000 vulnerabilities to a public mailing list? So with this, essentially they have a way to report privately, and you can work with them on fixes, etc., etc. TLDR, making security easy for non-security people, which is the way to go in order to scale this thing. Other things that others are doing is the internet bug bounty. Not that much active lately, but essentially they are putting money. So if you are in the deciding either go to the black market or to the white market, you can get some money here, right? They cover things like Apache or NGINX or Linux kernel. And if you find a critical enough vulnerability, they will pay you money for it. And they pay money for Heartbleed, they pay money for CellSock, Image Tragic, and all those, right? So clearly they are doing a good job. I was talking to Alex Rice from HackerOne, who are the main sponsors of this thing, and they are going to continue with the internet bug bounty. So we talk about what others have been doing. Let's go into the technical part of this talk. You may be wondering, it's like, hey, Fermín is giving me a lot of high-level BS. I want the meat, so let's go for the meat, okay? Two things that we're doing. First one, we are doing something called variant analysis for CVEs. So essentially what we do is we go through all the CVEs that happens every week, which I can tell you is something like 500 every week. We discard the ones that are closed source because, as I will later explain, the things that we can do, they are based on that we have the source code available. And we try to do variant analysis on those things just to see if the security researcher has missed things, right? Maybe they found the original one, but maybe they missed the 3 other ones in the next file, right? So we want to do that work for them. And the other thing that we do, and we will go later a little bit into detail, is that we provide this as a free service for open source that you can, if you have your source code in GitHub and it's open source, you can add a LGTM.com app, which is owned by Semmle, that you will have continuous analysis of your source code as you develop. Very, very similar to the fuzzing of Google, but we apply high quality code analysis to your thing. So let's go deep into Semmle QL. So essentially what we do is we compile your code, we extract all the properties that we can get from your code, and we store it in a snapshot. A snapshot, essentially think about a quite big database about references, assignments, everything that you can think, metadata that you can get from source code, we store it over there. And the idea is that later we are going to query that snapshot for properties. Usually they are very, very easy queries, such as Dataflow Analysis. I want to make sure that these inputs, they don't go to WinEsec if they are not sanitized. But we can go deep into the intermediate representation. For example, in this slide, you have a query for, and I think this query was provided by Microsoft, by the way. You have a query for an integer overflow check. And just because of some integer overflow checks, if X greater than int max or whatever, some of those, just because of the types and the promotion of types to a bigger type, usually sometimes they could be useless. So if you read the code, you could see, okay, there's an integer overflow here. Let's pass it. Let's go to the next one. So at some moment, someone figured out that this is an issue, and they codified this into a query. And this is the final query. I'm not going to go deep into explaining what this query is. There are other queries that they are way, way easier that we will explain later. But essentially, we can do automatic variant analysis. The idea is that with a seed vulnerability, you codify into a query and you apply to all your code base. You don't need to grep anymore. Who does grepping for vulnerabilities? Okay, don't be shy. I know that you do. So a lot of people does grepping. So this way, you are going to have guarantees that something that you found before that you codified into a QL query, you're going to get guarantees that you find all of them. Okay? The other product that we have is LGTM.com, which is free for open source. You essentially need to say, hey, opt in my GitHub repository. And this is an example of someone tried to fix something and they introduced a security vulnerability. So the LGTM.com plugin detected this pull request, analyzed the code, and found a new vulnerability. And I think this was probably minutes from when someone developed the code and from when we say, hey, there's a potential issue here, right? This is the goal. This is the goal of this second thing. Try to reduce try to introduce security in a very, very easy way as part of your DevOps, and make sure that the time gap between development and security finding is minimal, right? I think here, I cannot read very well my slide, but I wouldn't be surprised if it was a question of minutes until found it. So here there was a clear actionable description of, there is this vulnerability here, go to this code, check it out, right? Free for open source. You can go to lgtm.com right now. You can add any GitHub repository that's open source. There is even a console over there that you can type queries over there and play around. Go for it. Very, very interesting. And we talk about the Apache Struts vulnerability. But I wanted to give a little bit of history. And this goes long way back. So 2010, Meder, who used to work with me in the Google security team, found a vulnerability. And essentially, it was a OGNL script injection, essentially something that coming from the web request end up being evaluated as a OGNL, which means code execution in the process of the web browser. So someone else, 7 years later, someone else found another one. Well, 5 years later or 7 years later, then someone else found another one. Someone found another one. Equifax got hacked. And we were like, oh, there's a trend here. Why don't we try to codify this into a query and find the rest? So we stopped the trend. And this is what we did. By the way, this was done by my colleague Mo, who is amazing, by the way. So we did this. The Apache Struts vulnerability, and I'm going to go close to the sorry, no, don't worry. I will be here just because of the video. So I'm going to do, essentially it's a data flow analysis thing. We want to find places where actually source to sink. Source being the input handlers, where the request is coming from, and the sink is any deserialization methods in Java. So if you take a look to this query, and it's I had to reduce it, it's not the full query. The first two big parts, essentially we're telling, hey, this is a source. We want objects implementing this interface calling to the toObject function. That is a source. That is where we're going to the input that is untrusted from the attacker, right? And we did, the beauty of QL is that we didn't even need to define the sink. You know why? Because we have QL libraries that they are open source. They are in GitHub, github.com SemmleQL, that we already defined over there what were the deserialization sinks for Java. We have similar ones for Python and I guess for other languages. So we didn't even have to define unsafe deserialization sink because it was already defined as a QL library. So if you run this query a couple years ago, it would not only have found the Equifax vulnerability, but additionally one more. And there's another query for finding OGNL variants. So essentially, Equifax, even if they fixed their issue, they were subject to this vulnerability and some others. Now, Equifax, well, not Equifax, Apache Struts, if they are in GitHub and if they enable the NGTM.com integration, they could opt into this type of query. So as they keep developing, they don't, I mean, if you're going to make mistakes, don't make old mistakes. Only make new mistakes. That's the TLDR. And we provide a tool for, as you keep developing, if you introduce a vulnerability similar to the next one, it's not going to let you, and they are going to alert you within minutes. Let's go through quite funny one. So as I mentioned, we go through all the CVEs that happens every week, only on open source. So that's around 5. If you only consider open source one, 200, 300. If you only consider relevant, we go through 30. So Nico was doing that. Nico, my good friend, Nico Weisman, who we recently hired, and he found an interesting pattern in an open source package. Not that interesting, not that many users, but it was essentially a while loop with an array indexing thing. So he thought, okay, do I want to find variants on this open source package? It could be fun, but it would be nice if I do a query and I run it across GitHub, or I run it across some relevant packages. So he wrote the query and he ran it against the Linux kernel. He found 1,300 potential places, a while loop that could, they were dereferencing arrays, that there could be buffer overflows in the Linux kernel. Obviously, he said, holy damn, I didn't want to say that thing. 1,300, I cannot do this, right? I cannot go through this. I mean, it's going to kill me, right? So we discussed this and we say, why don't you go to Twitter and provide a query? We have LGTM.com, the Linux kernel is open source. Maybe someone can help, right? So we published the query, and literally something like 10, 20 minutes later, Tavis Ormandi, he said, amazing. Out of this 1,300, here's one that is actually exploitable. And later on, Linus Torvalds, a couple days later, he fixed the vulnerability. But let's go a little bit into the details. As I mentioned, there is the query. It was trying to find a really, really bad pattern that is a while loop with a condition, and inside the while loop there was assignments to an array, and there was usually this is not a problem itself, but most of the times there is no bound checking on the index, on the offset, on the X essentially, right? So he wrote the query. If you go through the query, the last part is okay. There is something that is part of a loop, and it's an assignment instruction, and the left part of the assignment is an array, right? So this query gave us 1,300 spots in the Linux kernel. And Tavis Ormandy from Google Project Zero, essentially he found this one, which is quite funny. It's like, right now I'm presenting here, so I had to plug my laptop into these fine guys projectors. And this is the vulnerability. If you plug in any untrusted monitor, this thing could happen to you. On that communication between the projector or the monitor and your laptop, there's communication, trusted, untrusted. I mean, we could argue about the impact, how likely you're going to plug your laptop into untrusted sources, but there's communication and things could go wrong, right? So our QL query found this one. Tavis spotted it and say, hey, this is vulnerable, this is exploitable, and Linus Torvalds fixed it. So this is the timeline. Essentially, Nico, he say, well, now you can find bugs in the Linux kernel. 20 minutes later, Tavis, he found it, and 2 days later, Linus Torvalds fixed it. But let's go into a more interesting challenge. This is a U-boot. We found 13 vulnerabilities couple months ago, and I want to go through the step-by-step process of how we found the original seed vulnerability and how we applied QL to find the rest, right? So what is U-boot? Open source bootloader. It runs on, if I'm not mistaken, on the Kindle Fires, Amazon Kindle devices. It also runs in Chrome OS ARM devices and in a lot of IoT devices. Supports verifiable boot, which means that anything that happens before the signature could be a jailbreak. Also, whatever happens after the signature check could be a jailbreak under some circumstances. And also, you need to think about the threat model here. Obviously, anything that is network related, it could be attacker controlled, is fair game. But also, file systems, anything like that, anything that you parse before you verify the signature of the kernel that you're trying to boot, should be treated as untrusted. Okay? So keep that in mind. Okay, let's now go into the next one. Okay, so the process that we're going to apply is that we're going to try to, first of all, keep an eye on the vulnerability counter in the top left. We obviously start with 0. And the idea is that we're going to find a seed vulnerability via code review, via fuzzing, via other static analysis tools, or whatever you feel like. And we're going to try to generalize that vulnerability into a QL query. And we're going to query U-boot to see if we can find other vulnerabilities. A quick hint, at the end of this process, which is going to take 10-15 minutes, the vulnerability counter is going to say 13 over there. Okay? So without further ado, we essentially find the C vulnerability, find a QL, triage the results, refine them as long as we feel comfortable, and go for it through, is this real or not? Okay? 1 second. So this is the seed vulnerability. I understand that we don't have a big screen here, so it's going to be difficult to spot it. If you want to, by the way, we have a challenge in our booth, which is in the other side of the hall. Where now that I think about this, if I give all the details, I can do the challenge. But in any case, in this snippet of code, there are 2 vulnerabilities that I found through code review. They are simple ones. I'm going to give actively giving you guys a little bit of time to say, hey, Fermín, here and there, right? So this code essentially is parsing some data coming from the network. In this case, it's an NFS request, network file system request. The vulnerability is that there are 2 mem copies that is copying source to destination. Usually there is a third argument in the mem copy, which is how many bytes do I want to copy, right? So this size, rlen, in this case, came directly from the network packet. It only went through one function, N2HL, which is network to host long, but still was attacker control. So just to be clear, we receive a packet, we read 4 bytes, and we fed it into a mem copy. This is the perfect vulnerability, because you control not only the source data, but also how much data you are going to overwrite. In this case, if I recall correctly, it was a stack-based overflow, or no, it was not a stack-based overflow, it was a global variable overflow. But in any case, we found these 2 vulnerabilities, and we started thinking about, this is very generic. I mean, if I can say Dataflow Analysis, source to sink, source being whatever it comes from the network, sink being the third argument to mem copy, and if it doesn't go through any sanitization, we have vulnerabilities here, right? So that's what we did. So again, keep an eye on your vulnerability counter. We start with 2. So we started writing a query. The first iteration of the query, you need to say, okay, give me all the memcopy calls, right? So we wrote the first query that you see over there, and apparently U-Boot has 596 instances of memcopy. I mean, a call side to memcopy, right? So do you want to audit almost 600 places? You don't want to do that. I mean, unless, yeah, you want to spend the next month doing that. So the second thing that I wanted to do is, okay, that's the sink, memcopy, right? The data flow is going to be source to sink, and that's the sink, memcopy. But we also want to define the source. And the source clearly is the NFS packet, right? So if we go back to the source code, there is a structure that essentially is dereferencing a buffer that contains the buffer that came from the network, right? So the source here, essentially I wanted to say, okay, the source is going to be any field access to a structure with the name reply. There could be others in the U-Boot code with this pattern, but great. I mean, this could not only be NFS, could be DNS, could be DHCP or whatever, right? So if you take a look to the number of instances that there is accesses to this field, is 191, and we have 596 memcopy call sites. So the idea is we want to merge this, and we want a tool that automatically tells me, hey, there is actually a data flow from here to there, right? So this is what we did. Essentially, a data flow analysis, source to sink, source from the NFS packet to memcopy. So there were 4 instances. 2 of those were the vulnerabilities that we found. So this proves that the query was good. It was finding the original issues. So now we have to look into the other ones, the triage, right? So again, we went from 600 call sites, almost 200 sources, to let's check only 2. These 2 is, the first one is, if you take a look to the source code, you may think, okay, there's actually a bounce checking. It checks if the size going later to the memcopy is not bigger than NFS 3_FH size. The problem with this is like, this would be a perfect check if this variable was unsigned. Unsigned meaning that it's not negative, right? But this variable was unsigned. So this check could be bypassed with a negative number that is going to lead to a huge memcopy, right? So vulnerability counter +1, so now we have 3. The second call sites is essentially, we started triaging the first one, it was valid. We started triaging the second one, and we found these other 2 other vulnerabilities in another function in the NFS that they were grabbing something from the packet, and feeding it directly to memcopy. Again, this is beautiful. I mean, I don't have to audit 600 places. I just feed it to a tool, codify it, spend 30 minutes with a query, validate that my query is good enough, finding the 2 original issues. Amazing, right? So we found 2 extra ones, but later we wanted to generalize it. It's like, okay, this is very tied to NFS. We want to expand it to the rest of potential networking packets. So we said, okay, we're not going to touch the sync, which is essentially the 3rd parameter of memcopy, but what we don't want to tie the source to the NFS packet. We want to tie the source to any operations of the network to host long function, N2HL. And this is the query. We found the 4 instances that we previously found, and we found more. So in this case, it's no longer in NFS, it's parsing UDP packets, and there are 2 integer underflows that later, these fields, they get fed into memcopy. So vulnerability plus equals 2. So right now we have 7 vulnerabilities. And at some moment, we started looking, it's like, well, this code is totally broken. Let's try to find more. Maybe later we can do another QL to find more issues. So we started looking around, and we found this pattern, which is essentially at each helper function, they were memcopying the source packet into a stack variable. So essentially you could feed 3,000 A's. So it's going to copy 3,000 A's into a stack control, a stack base buffer, right? So this was repeated 5 times, so 5 extra vulnerabilities. In this case, I assume that they tried to do the correct thing, where essentially it's like, okay, let's only copy whatever we can hold in that buffer, but they forgot that the packet length could be less than that buffer size, so they could be copying uninitialized variable, uninitialized data, right? So that's how we found the rest 6 ones. We could have written QL queries for this. We didn't, because at that moment we found so many. When we started counting the number of vulnerabilities, I had this feeling for whenever you go to the Costco, who knows about Costco? Okay, so you go to grab some meat, but you end up with a 1-year supply of toilet paper, right? So that was our case. We started looking for vulnerabilities. We end up with 13 vulnerabilities and say, okay, let's move on to other targets, right? So what we did essentially is something that a researcher could have spent a couple of weeks going through all the results. We did it in less than a day. This proves that the technology is very, very good. It's free for open source. You can check it right now on ngtm.com, open our web browser. There's a query console that you can right now do all these things to U-boot. Actually, you can grab these things and do them to U-boot, because by the way, they are not patched. There's a nice story around this. We told them in May. They told us, oh, nice, can you provide a patch? We provide a patch. Nice. We keep asking, hey, when are you going to release? Soon. Okay. We wait a couple of weeks. When are you going to release? Soon. At some moment we say, hey, we're going to present this in Black Hat. When are you going to release? And they told us, can you go public? So, okay, here's a patch, here's the advisory, and I don't think there is still a patch. So if you go to the GitHub repository of U-boot and you take these queries, you will be able to find these things, and I'm pretty sure that with some investment you will be able to find more. So as part of my role, I'm building I'm not only doing the corporate security of Semmle, but I'm also leading the security research team. We're hiring. Nico, please apply. I know you're amazing. careers@semmle.com, and we have a booth in the other hall. Please come talk to us. We have a challenge around U-boot. Not only this, plus extra things, and you could win some nice prizes, right? So this moment, I will take any questions that the audience have. Anything that you want to know about Costco, or I don't know. So we had this discussion around not all of them, they are vulnerabilities. We're talking about, the question is, what is happening to the 1,300 vulnerabilities in the Linux kernel? First of all, not all of them, they are vulnerabilities. They could be legit code with no issues at all. I always differentiate QL queries in two categories. The first ones are the ones that they are highly accurate. Those are the ones that we can put in a development DevOps process that you can essentially limit the time between development and vulnerability finding. For that specific case, you need highly precise queries. But there is another type of queries that is giving security researchers leads on where to look, right? So I wanted to clarify that one. That was a query on the second one. It's not a highly precise queries, but you don't need to go line by line to the Linux kernel to look for this pattern. So right now you have 1,300 for queries. We could have gone one step further to refine the query. So it's not 1,300, it's 100, but we didn't. Maybe we should. So we decided we don't have the time for doing this alone. Let's put it on Twitter to see if someone can help us. And Tavis from Project Zero, he helped us. He found one. Hopefully this is going to be enough incentive for you to take a look into the rest, right? I mean, we'll do some, but we also want to have coverage on other things that we want. So as I mentioned, this open source security is not something that any entity can solve itself. We cannot do it alone. We are calling you to help us. We are doing our part with Semmle QL analysis, going through all the CVEs that they are having every week. GitHub is doing other things. Google is doing other things. Maybe some of you have ideas to contribute to raise the bar of open source, which, by the way, we all depend on. And sometimes it's in the critical path of the success of your company. So if there's a TLDR for this company, keep that in mind. You like it or not, you depend on open source. You don't control it. You need to contribute back. And by the way, there's some other companies that they are doing amazing work, and we wanted to present what Semmle is doing. Any other questions? No? Yes? Please come talk to us. We're nice people. We don't bite. Happy to chat here if there is any other talk, or please come to talk to us in our booth. We have a happy hour party tonight, 7 to 10. Go to the Semmle website or the booth to talk to us. We can give you where to sign up. It's co-sponsored between Semmle and IOActive. It's going to be amazing. We can talk about vulnerabilities. We can talk about the 1,300 kernel issues. Don't be shy. Talk to us. Okay? Thank you.